Hello, friends. How's it going? Thanks for seeing me again today. If you didn't see me, if you slept in, the real developers sleep in and didn't come to the talk this morning, this one is going to talk about Linux on Windows. And who is using WSL today? So you know all this stuff. You don't even know why you're here. You know all this stuff. So this is great. So we have a medium-sized room, a small number of people. This is good. And we have folks that have been using WSL before. And you've seen the YouTube videos. You've used it in your daily life. So if you have something to add, if I make a mistake or you have a tip, so that we can convert the others that did not raise their hands, so that they might see the light. Are you waiting to be converted, or are you going to convert people? So you're already sold. Okay, cool. Because it's the year, have you heard? It's the year of Linux on the desktop. The Windows desktop, yeah. Where the sound card works. It's good. All right, cool. So I don't believe in slides, so we're not going to do any slides. We'll spend some time in Notepad here. And we'll talk about a bunch of different things. But I want to provide a little bit of historical context. So there was a thing called WSL1, and then there was WSL2. And now it's just WSL. So 2 is now not 1, but 2 is just WSL. So WSL1, the Windows subsystem for Linux, which really should have been called the Linux subsystem for Windows. It's not really clear why they didn't do that. There's some rule, some legal thing. WSL1 was really interesting because it introduced a concept called pico processes, tiny processes. Did anyone use WSL1 back in the day? Okay, good. It was okay. It worked fine. And the deal was that there's different kinds of binaries, right? And some of my, are there any Linux people here? Like old-time Linux people? Linux? You were like, did you not want, were you afraid we would attack you? He was like, ooh, I guess no one else is raising their hand. So I did Linux like in the late 90s, like when it started, right? And then did anyone do courseware in university where you had to use Minix? You ever heard of Minix? M-I-N, yeah? So Minix was literally the thing that started Linux. It was a tiny Unix system, and you would get a book, the big, thick, hardback book in university, and you would have to write the source code for this tiny mini Unix. And then you would get, for your operating systems class, you would get homework like write a file system. It's not quite the same as make a website, but it was our homework. And then Linus Torvalds, who actually lives in my town in Oregon, took that concept of Minix and then he ran with it, and then that's where Linux came from. So I've been a Unix head for 30 years. So there's different kinds of binaries, right? If I make a DOS binaries still exist on Windows. The first 2 bytes of a Windows binary is MZ, and I think the guy's like Mike Zawinski or something. Literally the first 2 bytes of the Windows executable format are this dude named Mike's initials. Because he was the guy. Like that was, he made it, so he got to put his initials there, and that was how that got that way. And I thought that was kind of an interesting flex to do that. DOS MZ executable header. Mark Zabowski. Isn't that great? Why? Because he just put 4D5A. So like that's the header that you look for when you want to start up an executable. Now, binaries on Linux are called ELF binaries. And they're a different kind of binary. And when you have your machine, you have user mode and you have kernel mode, right? The kernel mode is where all your drivers run, and then user mode is where your apps run. And what WSL1 did is it took the ability to have ELF binaries, Linux binaries, that I could copy from another machine, and I could then run them. And then every time we went from user mode into kernel mode, that moment, Windows would lie to the binary. Okay, let's think about this. We don't really think about this when we're working on regular apps, right? But when someone opens a socket or someone opens a file handle, who does that? It's not the app that does it. The app requests for the server, open a port to the kernel, open a port, give me a file handle, let me talk to this piece of hardware. Those are all kernel calls. In Windows, we call them kernel calls, or you call Win32. And in Linux, they call them syscalls or system calls. And there's a big system call table. And there's like the 80% case of like, here's the top 150 syscalls. And then there's the long tail of syscalls, which is like, here's the other 650. It's something like 800 or 900 syscalls. So what WSL1 did is you would take an ELF binary directly off a Linux machine in user mode, and it could like, open up a file and print something out to the screen. That's the job of that binary. So that means it needs to open a file handle, seek on the disk within that file, receive those strings, and then output them to the console. Sounds like the simplest thing. It's like a hello world type of an application. You with me? But there's no Linux kernel. So they're going to say, syscall 13. That's not a thing. So then we would grab it and then redirect it. So WSL1 was a big left-hand, right-hand broker. They would say, oh, that syscall maps to that Windows kernel call. That's cool. Except when this syscall maps to 3 or 4 kernel calls, or this 3 or 4 kernel calls maps to 1 on the Windows side, because the mapping was not clean. It was still pretty darn cool. But then there was the obscure syscalls. So like we got 80% working, and then 90% working, and then 95% working. And everyone liked it, and WSL1 was a success. And then some people would try it, and they'd say, have you tried WSL? And they go, it's crap, didn't work with my app. Well, why not? It works with my app. Well, it's because they were using an app that made some system call that was one of the ones we didn't map. And then each version got a little bit better, but for the most part, it's like, okay, we've got 99% of them. So then for people that it worked for, they'd say, this is great, it works great. And for other people, they would say, it doesn't work at all, it's trash, because it only takes one to not work. Now, processes on Windows have historically been heavy. This has been this way forever. This is just part of the operating system design of Windows and Windows NT. The cheapest thing that you can do on Windows to do extra work is make another thread. The cheapest thing you can do on Linux is make another process. That's because Linux processes don't really think about windowing. They were not thinking about putting buttons on the screen. So if you have a Linux process and you want to just make another one, you fork the process. It's incredibly cheap, microseconds. It's like that. But on Windows, every process has windowing behind it. It expects that it's a window. Even invisible apps think that there's a window. So forking on Windows is like 10x. Like an order of magnitude slower. So they made these things called pico processes. Let me go back to my notepad. And pico processes are tiny processes, because if we were going to map one process on Linux to one process on Windows, we would still be 10x slower. So every time the Linux ELF binary makes a call, it goes to the Windows kernel. The Windows kernel does the work. And then a pico process would show up in Task Manager. So you could look in Task Manager, you could see Bash, or you could see Vim. But it wasn't a Windows executable, it was a Linux executable. Okay? I'm giving you a lot of background, because this is what you want, right? You want the internals. And if you all know this, or again, if I make any mistakes, correct me. It's important that we get this right. Okay? So, then people get confused, and people of all ages and all skill levels, about the difference between a shell, a prompt, a console, and a terminal. And then they use those things interchangeably. They say, I use Cygwin. That's fine. I don't need WSL. You know what Cygwin is? Anyone familiar? I'll make sure. Some people are not. I want to make sure that everybody follows along. So someone will say, or I use conemu. I don't need WSL. So let's talk about these things. So Cygwin, a collection of GNU and open source tools that provide functionality similar to a Linux distribution on Windows. Similar. simulated. C is a lovely portable language, and you can compile C across any operating system. So the GNU utilities, and what does GNU stand for? GNU's not Unix, which makes it a recursive acronym. GNU's not Unix. They've recompiled the Linux utilities, awk, sed, vim, against Windows itself. So it's a simulation. So I can install that on Windows. I wanted to give you all like the real deal. So let's go to the terminal. We'll make it large. Winget search Cygwin. Love that high quality Wi-Fi here. So it looks like Cygwin is not up in Winget. So we'll go and run a random executable from the internet. What could go wrong? This is fine. You know you're on like the 1990s version of the internet when it's like the signature can be used to verify. And then I just said yes to an anonymous unknown object on the internet. So that's going to be, that's probably over for me now. I'm dead. Is it running? What's happening? Okay, I just installed a virus publicly. So what's the deal, dude? Are you running or what's up? Looks like it ran. I said yes. Pretty sure I said yes. Maybe I'll say yes again. No. What's happening? Install all users. Yeah, that's fine. That's fine. Whatever. YOLO. Available download site. This all looks very suspicious. We should all be wondering why we're doing this right now. This generally sucks. No, I just want to go back. What's happening? All right, we'll let that download. That progress bar is not comforting. So I'm downloading something very questionable from the internet right now. But what I'm going to show you is that if I should have probably installed it earlier. Wow, that's so speedy. It's 9600 baud. That's downloading a bunch of actual EXEs and actual DLLs. So these are going to be bash.exe and vim.exe and awk and sed. And if I run them, they're going to show up in Task Manager because they're Windows executables. This is, again, no disrespect to Cygwin. This is trash, by the way, because this is never going to work. No disrespect to Cygwin. It's not Linux. Why is that important to understand? Because we conflate these things. It'll let me run bash scripts. It'll make me feel comfortable. It'll let me type ls. If I want to type ls, that's fine. It's a Cygwin is comfort food, but it is not Linux. It is a user mode distribution recompiled. Now, when I say we conflate things, I'm going to go here into the Windows terminal, and I'm going to show you where it says default terminal application. And I'm going to give you a little bit more history, because that's what you like to hear, right? What is the thing responsible for painting on the screen? In that example application that we made in our heads, it spins through some files, it reads the files, and it says console.writeline, console.log, whatever. What's the console? Is that program that I wrote responsible for drawing pixels on the screen? No. It's responsible for taking a string and returning it to the console. What's the console? Well, on Windows, it's called conhost, conhost.exe. You've never ran conhost.exe. You probably didn't even know it existed. So let's change our default to conhost. By the time we're done, I'm sure Cygwin will have installed. Now there's 3 progress bars. So I don't know what that means. It's comforting to just stare at them. So I'm going to hit the run, and I'm going to hit CMD. And let's zoom in over here. Okay. This right here, CMD, if we look at this properties dialog, that will look familiar. Right? We've all seen this before. That's Windows 95 code right there. I remember when we got the ability to have TrueType fonts in the console. That's how old that dialog is. That dialog sucks so much that they're like trying to fit extra checkboxes in here, and you can tell that somebody did not want to make it taller because they probably weren't allowed to, so they just made the space between the checkboxes smaller. Right, so anytime anything gets updated in there, somebody just shoves it in as close as he possibly can. Right, like what is this? What is happening here? This is a nightmare. This is incredibly old code. There's nothing good happens in here. Nothing good is happening here. What if I type dir? What was responsible for that? Well, conhost is the thing that draws the box. That's a console. If I run PowerShell, let's run the blue one. It's not blue. Scandalous. Color. Look at this. Remember all of this nightmare? This is the same thing. It's got a different icon, but the same exact console host is responsible. This says command.exe. This is PowerShell.exe. And they're both outputting strings, and then conhost does the painting. So when conhost got upgraded to give you TrueType, everybody got TrueType for free. Now, here is a funny story for my old people, which is probably me. If I type dir/s, we're going to go through my entire directory. Really old Windows programmers know that if you have a log spew like this, the way you make it faster is you make it really small. Did you know that? Who knew that? Who knew that? You don't know why you know that, you just know that, right? Just like, and what's the fastest? You minimize it. Because it takes a lot of time to do that work because, God help me, it's synchronous. It has to paint, and it can only paint as it waits for the thing. So if you start painting, all the disk access stops. I love your face, sir, is pained. You're just like, what kind of architectural decision? What? And no one thought this was a problem? Why? History. Backward compatibility, just historical context. I mean, this is the console from Windows 95, and it's in Windows 11. It sucks, right? But to go and redo that is challenging. And people shit on Microsoft, and people pick on them for a lot of things. But I tell you, Microsoft does not get credit for backwards compatibility. With Apple, they're like, surprise, your Mac is never going forward to the next operating system. You're stuck. I've got a Mac Mini. It's been stuck on Snow Leopard from 2003. Because one day they just said, nope, we're going to abandon everyone from there, right? But you can run VisiCalc from 1979 on Windows 11. Like, they're obsessed. Because if we break something in conhost, we break it for 1 billion people. There's always somebody out there counting on a window handle or calling an API that they're not supposed to, and then we find out that, oh, we changed this little thing in conhost. What's the big deal? You broke all of the Coca-Cola machines in Mexico because some programmer was looking in memory for something and made an assumption, and you broke it. So that's literally the kind of stuff that I'm talking about. So this is stupid. You see how it's still actually going? What a nightmare. All I did was ask for a directory. That has like a maximum of like 30 frames a second or something. So there are now 2 console hosts. There's the Windows console host, and then the Windows terminal can act as one. The reason that there's 2 is because if we broke it, then you can switch it back. Okay? Right now we have about 98% compatibility, which is great, but that breaks it for 2 million people. Because a lot of people use Windows. So you got to know about this kind of stuff because it's super interesting. So now, if I go and say Windows R, type CMD, that's going to launch the same exact command.exe into a different console host. In this case, it's terminal. Cool? And now terminal is going to be responsible for painting. Except terminal is written from scratch. It's written in like DirectX, and it's written in C++. It's hard to the metal. It's asynchronous. It does like 1,000 frames a second, and it's a whole other thing. And it will work 99% of the time, 98% of the time, unless you, the console writer, are doing something weird. doing something internal. So already, you can see that that thing's just ripping along. It's going to go as fast as my system can go. Isn't that lovely? That's really, really freaking fast. It's even cooler. It can do things like rectangular selects. There's a ton of cool stuff that it can do. Now I've pissed off the whole thing. Don't rectangular select when you're looking at your entire hard drive. That was probably a mistake. And it also has this drop down here. This drop down does discovery, so it will look at your hard drive, and if it sees other other shells. It's hard, I gotta get the language right myself. If it sees other shells, it'll detect them, okay? So it detected developer prompt for VS22 and developer PowerShell because Visual Studio put a plug-in for terminal and it detected those. So Windows PowerShell is the classic one that came with Windows. Command prompt is the fake DOS that's been with Windows forever. PowerShell came from the Windows Store, that's PowerShell 7. And then Ubuntu, we're going to talk about when we get into Linux, and then the other two were detected. Now Cygwin, I can add to that list if it's ever going to install. This is just really special. We'll look at that another day. Imagine a world where Cygwin appears in here. If you go and run bash.exe with Cygwin, it's going to be a console app. So it requires a console host to paint its strings. Here's where things really get interesting. They were so offended by the console host, the original crappy one, and its support for ANSI and ASCII, color, and VT100 and terminal stuff, that they made their own. I think it's called like min TTY. Okay? And it is its own terminal. TTY is a teletype machine or a terminal end of something. I'll show you that in a minute. So min TTY is the Cygwin terminal emulator. Again, visiting these websites is like going to the 90s. And it has full Xterm support, secondary fonts, all these kind of things, emoji, yada, yada, yada. It's a vote of no confidence against the console host. Most of the things that they support are obscure. I'm not saying it's bad or good. I'm just trying to be very dispassionate about it. I'm not trying to sell you anything. All these things are open source, so I don't care if you use them or not. I just want you to know from an educated perspective why these things exist. You with me? So before they could have Cygwin, which is the collection of tools that fakes Linux, they needed a way to paint them reliably, because you might run Vim on our console host, and it might look weird, or an emoji might appear in the corner, or they might try to paint something and it'll be in the wrong location. So min TTY has better support. It's a different thing that paints on the screen. There's this thing, though, called the Pseudo-console in Linux that was never supported on Windows until we made it. In 2018, come on, Internet, we introduced con-PTY. There's a whole really, really interesting history of the command line, talking all the way back to how these terminals, this is Dennis Ritchie of C fame, on a teletype. So these original terminals would send ASCII on the wire. We heard about, remember the ASCII 10 and ASCII 13 this morning? Carriage return and line feed. Those get sent serially across the wire, and those would tell it to feed a line, or return a carriage. And on Windows, we would have dot matrix printers, so we would have a carriage return a lot. But on Linux, they only use line feed because they just wanted to feed the line, and there's no carriage here. So these would accept text input, buffer the input, put it on the serial line, and then display it. And back in the day, you might have a terminal like this that would speak a language called VT220 or VT100. These things still exist today. When I checked in on the plane in 2022, I could peek and see what they were using. It was a Windows machine running a text box. You've seen these. And it was running a text-based GUI that was probably a terminal into a mainframe somewhere. right? The Windows machine was really just a host for that kind of stuff. The modern stuff that you would see for that would be like Midnight Commander. Anyone use Midnight Commander? I'm going to the archives here, kids. Let's see if I have Midnight Commander. Winget search Midnight. There we go. Grab it. Winget install Midnight Commander. You ever use Winget? Is this the first time anyone's seen Winget? Like, what's that? What is he doing? So, first time? Now you're going to be using it. It's great. Yeah, so Winget is like apt-get for Windows, hence the name. And then what it does is it has a... oh, Midnight Commander's already installed. Okay, cool. Oh, yeah. Oh, yeah. Yeah. Everybody likes Midnight Commander. Remember that? Yeah, remember Norton Commander? Well, it was called Norton Commander when Norton wrote it. This is, you know who wrote this, do you? Who knows who wrote that? Miguel de Icaza. Yeah. Not just mono. He wrote a bunch of stuff. That was written by Miguel. And he wrote a really cool thing, if there's any C# people in the room, called GUI.cs. Check this out. GUI.cs. Console-based user interfaces in C#. Yeah. Is that a good feeling, or is that was that a shudder of excitement, or was that a shudder of like, no, not again. It's happening again. Why? Did you just say why? Why? I will tell you why. Here's why. This is me writing a blog post called "It's 2020 and it's time for text mode." And here's one from 2004. Windows is completely missing the text mode boat. I'm telling you, why? Because it's fast. It's freaking fast. It's stupid fast. It's never touched the mouse keyboard fast. It paints fast. There is nothing faster. No amount of, there we go, bring that back. No amount of hardware acceleration buttons with 3D shadows is going to be faster than freaking Midnight Commander, baby. So if you're making a terminal that someone is going to use only their keyboard on, and they're going to move around faster in text mode. Text mode is great. Especially the amount of communication sent on the wire is really minimal, and writing these in C# is super fun. So back to, I think it's hilarious, by the way, that this thing is still installing. Anyway, yeah. So this is running in the context of Windows Terminal, okay? So he's positioning his cursors and his stuff around the screen. And you see that moment right there? You see that? So what's going on there? What's happening is, let me make it larger. See how there's a flash? We're negotiating with the text mode about how many columns and how many rows there are. And that's all being done with like ANSI art. Anyone do BBSs, bulletin board systems? Yeah, my old friends here. I love you guys. ANSI art looked like this. You said ASCII? Are you correcting? Or who said that? So you call it ANSI? I think this is ANSI art. Rob, you say it's ASCII art? ASCII art uses letters, right? So when I was a wee lad, we would do ANSI art. ASCII art, which would be X's and O's and stuff, and we'd print them out on like foldable paper, and then we'd paste them up, and we'd have like a picture of Mr. Spock, but you had to stand on the other side of the room and squint, and it was just black and white. And then ANSI is what is printing out, like that's one character right there. And that's another character, and you print half characters. And if you look at the actual code, you'd see like a caret, and then a code that switches the color, and then the character itself, and then you'd switch back to the other color. So this is allowing you to send these things out. The original Windows console host doesn't let you do any of this stuff. It doesn't look right. So a great deal of work was done in the Windows terminal to support ANSI, thereby supporting backward compatibility and giving us the kinds of expectations that people have. There we go. Here's some, that's some ASCII art, right? So we see the difference there. So if I want to do something like this, and I want to draw lines like that that are smooth and attached, then I'm going to need to use characters that I would not ordinarily have. Okay? Yeah, oh yeah, I got menu. I forgot to show you that. We got menus too. Ooh, this is another great point. Look at this, friends. I'm using the mouse, right, in order to pick these things. So that is also mouse support that's in the terminal. All of that needed to exist and be supported before we could bring you Linux. So it's complicated. Like, often when you see things like this, or we had that conversation before about Cygwin, people like to put the word just in front of stuff. Oh, well, you're just running Linux on Windows. Well, there's a lot going on here, right? We've been working on this for like 6 years. And it's like, oh, well, we'll just run a virtual machine. Oh, WSL is just a virtual machine with Linux on it, right? Yeah, there was the pseudo-console, the architecture of the pseudo-console, the ability to have ANSI and ASCII support all the way up, fonts, the whole thing. So if we go back to our article about the software terminals and the separation of that synchronous painting out to the screen, how this terminal, the console stuff works, the entire architecture of that now brings me to what would old Microsoft do? They would come out with a terminal, say that's the terminal, and then they would kill conemu and min-TTY and on and on and on. There's a whole ecosystem of things. We don't want to kill Cygwin. It works. Conemu, anyone use conemu? Great little, yeah, a couple people back here. We don't want to hurt them. So what we do is we make an interface of console application services by which they can then call that. So now the new versions of conemu and hyper and console Z, these are on Xterm, these are all consoles that are part of the third-party console ecosystem on Windows, any one of which you can do. I want you to be able to run bash in whatever terminal makes you happy, right? I like this one. You could use conemu. Everything works the same. So these APIs are all open to the public, and they needed to exist before we did these other things. Okay, so back to our, man, you just are just winning at life right now there, Cygwin. Okay, so WSL did not have a Linux kernel. It only ran user mode stuff, and it was super fast on the Windows file system. Why was it super fast in the Windows file system? Because they were little tiny Windows processes. That makes sense. A lot of people talk about performance issues with WSL as it relates to file systems. We're going to get into that a little bit. The better question, rather than memorizing, well, if you use this on that file system and this on that file, is to understand the why. WSL are really Windows processes, therefore they will be fast on the Windows file system. WSL2 uses a utility virtual machine. So then this is where we start saying words like just. And I don't like saying just in software because it minimizes people's work. You all are working on cool stuff at work, and if you told me about your cool thing at work and I said, oh, that's just, and then I named another product, you'd go, it's kind of my life's work. Thanks, right? You'd feel sad. You've been able to run Hyper-V VMs for years, right? You've been able to run Hyper-V, VirtualBox, VMware, etc. These are all hypervisors. What's good about them? They let you run other operating systems. What's bad about them? They're heavy. Hey, here's a virtual machine, 30 gigs, plop, right? Boot it up. Okay, let's wait 15 minutes. And then you end up with a square inside your square. Right? Here's your host, and here's the virtual machine inside it. And then we try to hide things. We try to make it so you can drag and drop from the inside to the outside or the outside to the inside. Parallels does this really great on a Mac. It goes out of its way to lie to you to make you feel like you're not really running a virtual machine. Other problems with virtual machines for this solution are that it doesn't work on Windows Home. That would suck if you had to buy Windows Pro just to run Linux. So we went out of our way to make sure that you didn't need Hyper-V to run WSL. Here's where it gets confusing because Microsoft. If you go out to the Start menu, you type in Features, you go to Turn Windows Features On and Off, and you get to this dialog box from the 90s. You've got that, which you need to turn on. You've got these two things, and I don't know the difference. And then you've got Hyper-V proper. Hyper-V is like a meta checkbox. It's the install everything I need, including that ugly Hyper-V client thing that lets you manage your virtual machines. The hypervisor platform sits underneath that, but all you need for Windows Subsystem for Linux is virtual machine platform and WSL itself, and that works on Windows Home. That works at your house now today. And that's cool because kids that are in university are going to want to run Bash. Now they can, and it works great. They won't have the ability to run full-blown hypervisor type stuff. This still uses the hypervisor and the VT extensions to Intel and AMD, but they don't run, full boxes. But it's cool because it works. So when we say utility virtual machine, we want to be able to create a small, fast VM that starts up quickly, that has a real Linux kernel. I don't know how to spell kernel. Kernel? Kernel. It's one of those. I don't know. Okay. WSL Linux kernel. There you go. There is the source code for the Linux kernel that Microsoft uses on your machine. This is really important. It's a real Linux kernel. It is the Linux kernel. It's got some little herbs and spices that they've added in it to make it work better on Windows. But it is Linux forked and followed, and then it's got a little spice. And I'll show you that spice in a little bit. Okay? But it's important that you know that that's there so you can go and see it and compile it. Even better, you can swap the kernel out yourself. So it's literally a Linux kernel on a file in Windows System 32. And if you don't like it and you want to hack on it, you can write your own and replace it. It's definitely not your grandparents' Microsoft. Any questions so far? All right. This has been going on for a while. 4 years ago we started this. So if we come out here, and I'm in fake DOS. And when I say DOS, I mean like, DOS in quotes. And I can type dir and stuff like that. If I type WSL, I immediately have a prompt right here. See how fast that was? 1,000. Okay. LSB release -A. That's Ubuntu 20.04. That's not Microsoft, this is important, that's not Microsoft's Ubuntu. That's Ubuntu from them. Now remember all that conversation we had about the difference between kernel mode and user mode. The Ubuntu that we're using is not shipping the kernel. It's the user mode file system for Ubuntu, tarred up, that means zipped up, tarred up, and then simply downloaded via the Windows Store. They stick it in the Windows Store. We're just using the Windows Store as a content distribution network. Otherwise, we'd stick it on GitHub. And then it untars. And then it uses the kernel that we already have. The kernel is the Windows kernel for security reasons, the Windows Linux kernel. And it gets updated automatically, or you can run WSL-update and it will update for you. You don't really have to do anything about it. We've recently put a preview of WSL in the store. In the past, you'd have to run Windows Update to get updates to WSL. Now you can just get it from the store itself, which means you don't need a new version of Windows to get new features. So we're actually adding new features to WSL from the store. But I want you to understand the separation of those things. It's super important to understand that. You saw how fast that started? That's not a VM the way you think of a VM. Now if we go to the store and we literally search the Windows Store for Linux, doesn't it all make you feel dirty? Don't you just like, am I supposed to be here? I just feel a little bit questionable whenever I do these things. You got Kali Linux. There's the Linux preview I was telling you about. You can just install this over the top of the one you have. You've got SUSE. You got all these different Linuxes. I could go, let's install a Linux actually. I think we've got Alpine. You got Oracle Linux. Is Alpine in here? Alpine WSL. So I got two ways that I can install this. I can push install, or I could do it from the command line. So I could literally push install, but I'm going to be at the command line. I'm going to type WSL-list-v. Those are the Linuxes I have running right now. Docker installs its own. I'll explain that to you in a second. Ubuntu is marked with a star. That's the default. So when I type WSL, I get Ubuntu. I can get whatever one I want, but that's the default. I can say WSL-install, and I think it's, or is it WSL install? Let's see. Go back. Crap. Is it -D? Thank you. You know, there's like dash install and dash install and 1-2 install. -D for distro Alpine. Is that right? Well, now you said there were no still. How many dashes do you want, man? Let's go. 2 dashes? Are you sure? Let's try this. WSL. I don't like DOS. I'm going to go to PowerShell because it's prettier and I have a cool background. WSL list online. There we go. Ooh, okay. So -- install -D. I think I can get Alpine even though it's not listing it. Alpine WSL? Man, you suck. Maybe I need to get it. Maybe only certain ones are here. I'm going to try anyway. So I could say install -Debian, and they would go and get that. I don't know why Alpine's not showing up in the list. It's probably not like officially allowed or something. Let's go and see where Alpine is. Something going to happen? Oh, here it is. It's untarring. There's the tar. See up at the top there? Second line. So it's doing some things faster than Cygwin. Just saying. Just saying. All right. Now we're in Alpine. Okay. Go back out here. See? Now I've installed a Linux. It's that fast. That was pretty fast. Now where'd Cygwin go? Okay. That's a little small. A little small. It's a lot small. Come on, Cygwin. What are you doing, man? This thing, you can tell it was written in a time of distress. But I want to point this part out here, that the console of Cygwin is not the same one. The host is different. That said, though, if I wanted to, there we go. Like if I run Vim, so I can't, they don't have Vim? You have VI? Defaults to Vim. Okay, I mean, thanks. Let's see if we can see terminal. That Cygwin is installed where? Right-click, open file location, right-click, open file location for real. Sorry, it's small. I'll make it big in a second. There we go. Just wanted to make this point. Okay, those are Windows executables. Okay. Now, when we ran Cygwin, that means when I'm going to close their terminal thing because it's stressing me out. And I'm going to right-click on this, and I'm going to say Open File Location, and I'm going to look at this at the properties. And I'm going to look at the target and open that up in Notepad to make it larger. Okay? So it looks like they're running this thing, min-TTY. So that probably means I can run that down here. And that's going to default to some stuff. And I can go in here and figure out what does it really mean? Like, what are we running for real? And could I add that to the Windows terminal? You follow? So I'm going to right-click and say Open File Location, and I see is there a bash in here? Here's a bash. I'm going to right-click on that and say Copy as Path. We'll come out here to Fake DOS. Where's Fake DOS? There we go. I'm going to paste that in. Okay, so I just went from Fake DOS to Cygwin. So now I know how to run that. So then that means I could go into Windows Terminal, hit Settings, say Add a new profile, new empty profile, name it Cygwin, command line. I betcha, I'm guessing here, I've never done this. Starting directory, I don't know. Save. This might work. Could crash everything, who knows? Maybe it is crashing everything. I may have broke something. You mad at me? What's happening? What's happening? All right, I have no idea. Let's try it. Go away. Okay, here's Cygwin appearing in the list. Ah, you see how Alpine just showed up? Got detected. There you go. So Cygwin doesn't know that it's running in a different thing. It just outputs strings. But you see how it's color? It's outputting ANSI control codes, which terminal understands. So that means that if you use like Anaconda or Python or whatever, you can put whatever you want in here. Now I just got Alpine up to appear, and we saw that over here when we said WSL-list-V. So I can say now WSL-D Alpine and run it immediately, or I can pull it up from here. Now because I'm using the Windows terminal, I can hold down Alt with one finger and click on these things. So now, I'm just doing that multiple times. We've got Ubuntu, we've got Alpine, and we've got DOS, and we've got PowerShell, all in Windows terminal. Okay? Then I can hit Alt, Enter, and go full screen and pretend Windows doesn't exist. Then I can hit Control W, Control W, Control W, Control W, because I've gone into Windows Terminal and I've mapped Control T for new tab and Control W, which are the things I use in my browser window to open tabs and close windows, and I mapped them in here nicely as well. So if we go back into Ubuntu and we type in df, we can actually see the file system. We see a couple of interesting things here. The most interesting thing is here, Mount C. Remember at the beginning of the conversation, we said that WSL1 is really fast because they're Windows processes talking to the Windows file system. On WSL2, if you are talking to the Windows file system, you will be sad. It will be about 5 to 10x slower because you're talking to a mount point, to a remote drive that runs a different file system. It's not the same file system. You can think that that's a limitation. Yeah, they're going to do the best they can, but they're probably only going to be able to get it about 30% faster. But if you write to the Linux file system, which is up there at the top, you're writing, in fact, to a hidden VHD, which means that you're bypassing NTFS, you're bypassing Defender, and you're running at full speed. It's within 3 to 5% of native Linux speed. So your first thought might be when you get this, you're like, oh, I've got Bash, I've got Vim, I've got all the things I want to do. So I'll go to C, users, Scott, desktop, and then, party, git clone, go nuts, right? But what's wrong with that? It's going to be firing off changes to OneDrive every time I hit something. It's going to be fighting with NTFS. All of my Linux files are going to be looked at by Defender or whatever. All of that's complicated. So what you want to do is you want to stay on the Linux file system. So I've put my source code here. So here's my website. I keep typing dir. Okay? Now, here's where things get weird. Remember how I said that there's some special herbs and spices in our kernel? You all know, because you're programmers, that if you run Vim, you can't exit ever. You just have to shut the computer down, right? This is just part of the world. But now you can just shut down the virtual machine. Here's where we offend people. You're either going to be offended, or you're going to think it's amazing, or you're going to think both. And a mumble went through the crowd. Is this being recorded? I hope not. Because somebody's like, this is bullshit, Microsoft, you suck. You know, they made it 52 minutes into the talk, and then that was when they broke me. And then Hanselman ran Notepad from Linux, and I was like, that's unacceptable. If you run a .exe, here's the little herbs and spices. We have the Windows path in your Linux path. Yeah, it's nice, yes. And if we see that MZ, Matthew Zawinski's name or whatever, we go, I can't handle that. I'll let Windows handle that. Isn't that freaking awesome? Like, why not? Okay? So then we had to update Notepad. Remember how I said that we didn't just do anything? There was a cast of thousands involved in this stupidity. This is amazing. So we won't mess up your files, okay? So now, what if we did this? What? We actually run a Plan 9 server, and it's your local machine, so it doesn't go over the network. You have access to your Linux file system from Windows Explorer. Why not? Because it's awesome, right? How freaking cool is that? Remember when I said at the beginning that you can run a square inside another square? Does that feel like there's any squares involved? It's completely blurring the line between what's possible and what's not possible. So then why don't we just put a freaking tux in Windows Explorer? We did. Thank you very much. So now, if I click on the Linux tux, all of my Linux distributions appear in Windows Explorer. Yeah, that's good. Okay, so then what if I run .NET on this machine, and I run .NET run to run my website? That's going to start up on localhost. Who's localhost? What is localhost? What is life anyway? Right? We live in a society, nobody knows what's happening, cats and dogs living together, mass hysteria. What's localhost? Who's localhost? Local to what? What does localhost mean? It means your computer. But this is another computer. It's a virtual machine. So Microsoft really works hard on this, and the developer division, DevDiv, where I work, works on what's called the principle of least surprise. Right? I'm not joking. This is a real thing. When we have conversations about what would the customer expect, what would be the least surprising thing to do, right? We also do a thing called the pit of success. When the customer falls, they fall into the pit of success. So they're going to go and they're going to click on this. By the way, you notice that it underlines when I put my mouse over it? That's new too, Windows Terminal. That way I can click on it, right? So now it's hit localhost. That's interesting. Let's run TCP view from sysinternals and look at our ports. You see that? Remember how there's a kernel involved here, but it's got to deal with another kernel. When you listen on a port on a computer, you get one port and one process. So that means we've opened up a port, 5000 and 5001, but it happened inside Linux. We wouldn't want someone to hit localhost 5000 on the outside and get confused. We couldn't open another port there. So we have a WSL host hold that port open, and it port forwards transparently. So localhost is your computer, that box right there, regardless. Isn't that cool? Yeah, that's the least surprising thing that would work. It works really, really well. That means that I can run my application, my Node app, my Ruby app, or whatever, and as soon as we see someone bind to a port like that, we make it available to the outside, but the outside is just my computer, which is really cool. All right? When I run htop, I can see all 8 processors on my machine and all the memory that I want, because it's my machine. There's a config file, a hidden config file you can set to decide how much memory you want the system to use, and it will grow or shrink depending. So right now it's using a lot of memory because I'm running Docker, but ordinarily it only uses about 400 or 500 megs, and it grows and shrinks appropriately. So then, what would be an incredibly amazing and stupid thing to do? Let's install the GIMP on Ubuntu 20.04. How to install the GIMP? Google in with Bing. Ba, 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 ba. Okay, let's go over here. I'm just going to copy and paste whatever the internet tells me to copy and paste, because that's what you do. Just copy paste from the internet. This is fine. What could go wrong? I'm running apt-get update. Da, 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 da. That's not too bad. Installing a bunch of stuff. When people go on the internet and they're like following instructions and they have a Windows machine and then it says, hey, you want to install this thing? Go to your terminal, and then they show the $sign, and the Windows person says, my thing looks like a C:, and they don't feel included. Now you can just do that. These things work. You want to install Redis, you want to install Mongo, do it. It works just fine. The other cool thing is that I can go and run applications on Linux, and I can work on them on Windows. I can work on Windows and target Linux. I can do all kinds of stuff. While this is coming up here, I'm going to open up another Ubuntu over here, running simultaneous. I'm going to go into that folder, Hanselman. I'm going to type code dot instead of explorer dot. Visual Studio Code starts up. In the corner, you can see it says WSL Ubuntu. If I hit Control tilde, that gives me a terminal inside of Visual Studio Code for Linux. If I say Control O for open, to open up a new file, that's the Linux file system. I can now, in Windows and a Windows app, work on my application on the local or the Linux file system. And when I hit F5, I'm debugging from my Windows app over to my Linux app. I can do this in Visual Studio proper as well. So in Visual Studio Senior, I can hit F5 and debug as well. The other thing that I can do is I can run Docker. So let's close this one. The GIMP was going really fast, and then it got slow there in a last second. And we'll go over to our GitHub folder. And I'm going to say Docker build. And now I am building in Docker. Docker on Windows uses the Linux subsystem as its underlying platform. So that Docker distribution that we saw is Docker's little partition, its little space. So now I've got my application completely built on Docker, and I can also click a checkbox and run Kubernetes as well. The GIMP is not going to work very well right now because the internet here sucks. So instead, I'm going to click on, let's go and say apps U, and I'm going to open up, where did that one go? Here we go. Here's an app in my start menu on Windows when you install a GUI application with WSL, we put a tux over it in the Windows Start menu and detect it automatically. And then when I click on it, it starts up full speed. So this is a Git application that lets me look at my Git tree. You saw how fast that started. So I can look at the history of my application. The GIMP would start just as fast. You see how it looks like a Linux application because it is one? That's a local file system. How do you think that's so fast? What's going on there? Any thoughts? Any guesses? Well, we got Explorer working by doing that local file system thing. We just made it a file system and Explorer can look at it. That's a local remote desktop. Remote desktop is hardware accelerated. 3D hardware accelerated. That means I can run, like, if I wanted to theoretically, emulators. Like I can run the Dolphin emulator for a Nintendo 64 at 60 frames a second. This isn't like slow RDP like back in the day. That is hardware accelerated. And we have a separate distribution that manages all the hard stuff. Seems like something you could break or mess up really easily. Sound works out of the box. 3D acceleration works out of the box. All of that's done in a hidden distribution. So you've got your Ubuntu Linux distribution, and then all of the hard configuration stuff is pre-set up in a hidden partition that you can't mess up. And it's super fast, as you can see. All right, and this is the, you can see the difference actually. I don't know if you can zoom in or not, but you see how the mouse changes when I get in there? See how fast that is? It's pretty sweet. So all of this is, in my opinion, made, I like Windows, I like the Windows desktop, I like Windows 11, I like my hotkeys, I know where everything is, but now I can go and target on Azure or whatever, .NET, I can pay 30% less because there's not a Windows tax. I can put things in containers. I'm learning more about Kubernetes. If you're a Mac person and you're wondering what the hype is about, you can run Linux on Windows and it runs really, really, really well. Any questions? We are 4 minutes over.
What happens if I run code, but instead
Yeah, that's a good question. So the question is, what if he wants to run code by installing it in Linux, right?
No. The same code that you ran, but instead of docs to open Visual Studio Code there, if you point to this, the mount of C inside Windows.
Yeah, so you'd be in Linux running a Windows app, pointing it to the mount point?
Yeah.
That would probably be a bad idea. Let's find out. I would probably not do that. I think at that point you're asking for trouble.
Yeah.
I think the first question is why would you want to do that? So I'm in Linux on the mount point. Now you want me to do that?
Yeah. What happened? Okay, so it starts the.
Yeah, it's like do you trust it? It says don't do that. So then my question to you would be, do you hate yourself?
Yeah.
Or do you want to learn more? Yeah, don't do that is the answer to that question. I think the point that the gentleman is making is a valid one, is that we are going out of our way to tell you don't do that. If you choose to do that, you will be sad. So yeah, don't do that. I don't know why everyone is moving so slow right now, but yeah, our internet's not working. The GIMP is Photoshop for Linux, and it runs full speed, and it's great. It's fantastic. Good question. That's a good question. Let's go here first. Oh, there's another great question. So if you're in VS Code and you use WSL, VS Code will prompt you to install different extensions like remote containers, remote SSH. That remote thing, opening a remote, isn't specific to WSL. So if you're using Raspberry Pis and you have SSH into the Raspberry Pi, you could develop on Windows SSH'd into the Pi, or any remote Linux system. It's not specific to WSL. And then if I go and say, open workspace from file or something like that, there's a section here where it says, well, I want to open it from a container. I can do development inside a Docker container. I can do it from SSH or from WSL, and WSL will notice that you're opening something in WSL and say, hey, let me reboot and start up again. And what it does is it splits Visual Studio Code in half, which is a good thing. So extensions, check this out. Let's go back out and let's go Ubuntu, make the font bigger, Hanselman, code dot. Okay, I'm going to go back out here. I'm going to open another Ubuntu to make the point, and I'm going to hit htop. I need to fix my colors. There it is, right there. Visual Studio Code notices that it's never been run before, then installs a server that does called the language, the LSP, language server processor. What's LSP stand for? Language server protocol. So the LSP host. So when you're typing your code in Rust or Go or C#, and you type like foo dot, and there's a dropdown. Who populated that dropdown? The language server process, the language server protocol host. Some host had the context on .NET, which is what I know more. It's like Roslyn knows what to show you. You see? So that's running over there. So in Visual Studio Code, your extensions live in a host of their own. So if you click on extensions, look, these are the local installed extensions, or that's the one that's installed inside of Ubuntu. So you can mix and match your extensions. And that brings me, and we're out of time, to what are called dev containers, which are genius. And if you want to go to my YouTube and look at my development work that I did with Jan de Dabelier from Oh My Posh, he does his work in Go. I didn't want to install Go. So if you want to work on Oh My Posh, you clone his repo, you open it in Visual Studio Code, it has a .dev container folder with a Docker file. It describes everything you need, including the extensions that you need in Visual Studio Code, and says, hey, this is a dev container. Fires up a container, builds everything, installs the stuff you need to do the work, and then runs VS Code against the server that runs in the box. That's how CodeSpaces works. It's the same technology, the same concept. Visual Studio Code is a client-server application. Every one of those extensions can live in its own container and be remoted with these different protocols. Isn't that cool? It is cool. It is deeply, deeply cool. Yeah, it's fundamentally the biggest thing to happen, in my opinion, in software in a long time, because then I can open up Visual Studio Code to a remote dev container. And I could have a Chromebook with 64 gigs of RAM and 16 processors, something like that. All right, get out of here. I'm sorry, I'm talking too much.